Have you ever wondered what inside colorful drinks and desserts? Today, I'll show you how to separate those colors using a simple technique that called pepper chromatography and compare it to a powerful lab method called Hplc. The pepper is the stationary phase, the solvent is the mobile phase. The sample is placed above the solvent level and a solvent moves up the pepper by capillary action, carrying different substances at different rates based on their polarity and solubility. Pepper chromatography is a technique used to separate mixture like food dyes. Firstly, we're going to cut at the end of the pepper chromatography. They don't have to be exactly the same. After that, using a pencil and ruler, gently faintly mark the origin. I use paper clip and sticks to set up my project by label my solvent at the sticks. Why I chose acetone, ethanol, and methanol. Acetone is a moderately polar solvent, ethanol is more polar than acetone, and methanol is the most polar of the three. I use food coloring from Star brand, which is common in Malaysia. The blue dye contains beryllium blue FCF, which are a polar and synthetic dye. The green dye is a mixture of beryllium blue and tartrazine, a yellow dye. So when a green is tested, it often splits into blue and yellow bands. I use the tip of needle to make a small dot on the pepper. For this phase, I mix blue and green. This way, I can observe how each color moves on its own and also how they behave when mixed together. Then, I dry the pepper so the color won't spread before I put it in the solvent. I use 2.70 ml of solvent in each beaker. As I go through the steps, I will also explain about the polarity and the solvent. When the solvent moves up to the pepper, it carries the dye components. Dyes that are more soluble in the solvent move faster, dyes that stick to the pepper move slower. Normally, methanol is more polar than ethanol and acetone is less polar than both. But in my result, ethanol looked more polar. This might happen because the blue and green dyes in the food coloring dissolve better in ethanol. Also, the dye may form stronger bond with ethanol, so the color moves more with ethanol on the chromatography paper. I mark the solvent front using a pencil. This is the highest point the solvent reaches on the paper. Sometimes the solvent moves but doesn't carry any color. So marking the solvent fronts help me to see how far the solvent went with or without the color. To compare how far each dye moves, we calculate the retention factor RF value using this formula. Pepper chromatography have some limits. Sometimes, the substance don't separate clearly and the solvent we use affect the results. Also, it's mainly qualitative so we don't get exact identities or amounts. Let's compare with high-end instruments like Hplc that give more accurate results. High-performance liquid chromatography (Hplc) is used in lab to separate and measure chemical components. Hplc separate components in a mixture based on their interaction with a stationary phase and a mobile phase. Different substances move through the column at different speeds depending on their chemical properties like polarity or size. It works by injecting the sample into the high-pressure column. Each component exists at different retention time, and a detector creates a graph called chromatogram. It's highly sensitive and accurate even for colorless substance. So, let's see what is the difference between pepper chromatography and Hplc. Let's look at the advantage and disadvantage of paper chromatography and HPLC. Paper chromatography is a simple and low cost. It doesn't need expensive equipment and it's easy to set up, but it has some disadvantage. It's slow, give only qualitative results, and can't separate complex mixtures well. On the other hand, HPLC gives fast, accurate, and precise results. It can separate complex mixture and give both qualitative and quantitative data. But the disadvantage is that HPLC is expensive and need trained people to operate. So that's how we separate and identify food dyes using chromatography, from simple paper strip to advanced machine like HPLC. I hope this helped you understand more about how chemistry works in real life. Thank you.